Okay, sorry about that. My internet dropped again, and it's not good actually. Yeah, I got some. I don't know if it works because like I just do the internet test. By the way, you have seen it. Um, but my OBS is saying that it's not good. So sorry about that. Yeah. It's a pain. I don't know. It works better at night. I don't know if it's the heat or people at home in the weekend and watching TV or whatever is really bad. I have to investigate that. I don't know. Do you think I should buy a Starlink terminal? Like, yeah, it's incredible. Like living in the middle of like in a city and then the internet's not good enough. We need a Starlink terminal. Ah, okay. Sorry about that. And I know someone was watching before, but it just unfortunately get dropped suddenly, and so sorry about that. Yeah, there are some lagging as well. I'm watching the stream right now. There's some lagging. Bear with me. I don't know what to do. I don't know what to do about it. The internet thing, like you won't believe it. Like London is a very modern city, but internet infrastructure is quite bad in a lot of like residential areas. So I don't know. I don't know. So maybe Starlink terminal is the solution. Okay. Anyway, we have to move on. We'll solve out the internet problem in the future. So we were just talking about scope. So it was fun because yeah, if we pass the string into a function and it go out of scope and then you can't it won't work. It's gone after you've passed it in because there can only be one owner to the string and you have passed it. You have given it to someone else, then you don't have it anymore. So return value can also transfer ownership. Ooh, so for example here, so S1 give an ownership and then S2 is a string and then take and give back S3. So what's going on here is that this function give S1 something and then S2 come into scope separately. So you give S2 to another function, but the other function give you back and then you now assign to S3. So now before we enter scope, right? So we will have S1 and S3. S2 is no longer valid because we have passed it. So now we have to drop S3 and S1, I guess. Yep. S2 has been moved, so nothing happens. So only S1 and S3 need to be dropped, and they're only accessible. So S2 is gone basically. Give ownership is just creating some string and give it to someone from yours. And so take it, give back, you take it, and then give it back here, return. So, right, interesting. So knowing that, so yeah, so if you at the end of it, it won't get dropped. It will just return and move out. So it will give the ownership to someone else. Yeah, so it won't get dropped. And return multiple values. So we have that. So we have a string. We have a calculate string. So we give the string into it, and then when it come back, we will give back S2 and the length. So the length of S2 is the length. Yeah. Okay. This is too much ceremony. A lot of work. Oh, Rust has a feature so it's called references. So yeah, so if you want to, for example, like print out the result, because you still want this string, so if you give it to a function, then you give it away. So this function needs to give it back. So then you have to return it as a tuple like this, which is very a lot of work. So we have another way to solve this problem. So let's have a look. Right. So now, again, you have S1 and then you have calculate string and then you have the length. So this time, instead of moving the ownership of S1, we pass it by reference. So now we have the n. So it's only passed by reference. So calculate length doesn't own it. It just return back the length and then come back. So let's see what's going on here. You can see a beautiful graph. So S1 into calculate length. Okay, so we now have a string. So this S string, actually this is a reference, so it's only reference to S1, so it doesn't make a copy of S1 and own it. So yeah, so this is what's going on here. So it's passed by reference. Yeah, this is like very common if you like, you know, have learn other programming languages that have the S1 like if you have learned other program that also have passed by reference, then it's the same thing, right? Like is you just pass by reference, I guess. Using the n% is a pass by reference. The reference operator star. So we'll use the reference operator later as well. So now we're just using n. N is passed by reference. So this need to have the n, this need to have the n to pass by reference. Yeah. Create a reference and refer to the value of S1. It does not own it, it just reference to it. And that's it. So, yeah. Right. So S won't get dropped here because S is only a reference. It does not have ownership, so it does not drop anything. But then when they finish here, then like, yeah, then it will. Function of reference parameter. Yep, it won't return, it won't get dropped. Borrowing in real life. Give it back, you don't own it, never own it, you just borrow it. Modify something that we are borrowing, okay. It doesn't work. Okay, so hello, and then change, pass by reference. Then we add something and then come back. And then, oops. Here's the error. Oh, because this is immutable, right? We are not allowed to modify something. We have a reference to, yeah. So it's still bound by the rule because now this one owns it, and so the main still owns it. So want to change something, but S is immutable, so you can't change it. So if you want it to be mutable, you have to make it mu. So mutable reference. So you use mu instead. Yep. So you have to make it mutable if you want it mutable. And then right. Okay, I can do that as well with the mu. So yeah, instead of n we use mu, and the thing needs to be mutable itself. So you can change it, so this time it will work. Mutable reference have one restriction. If you have a multiple reference to a value, you can have no other reference to that value. So this one will fail because you're creating two mutable reference. So yeah. So you can't, because then you have two things that potentially change at the same time, so you can't do that. We have an error. So something can't be borrowed as mutable more than once. This is what is happening. First borrow is and must last until it's used. Very controlled, yes. Yeah, this is, yeah, I can see why like people don't like it. It's very different from everything else. Yeah, most languages you can mutate whatever you want. Hmm. Data race at compile time. So yeah. Being used to synchronize. Yeah. Two or more pointer access the same data at the same time. At least one of the pointer is being used to write the data, and then there's no mechanism being used to synchronize. So yeah, like what if both of them are mutable reference and try to access the data at the same time and try to change it at the same time, right? So no, so it's called data race, and it's yeah, it's difficult to diagnose. It's kind of random, right? You don't know what's going on. Track them down at runtime. Yep, you just can't use data races. You just can't have an arbitrary order of who is accessing and changing the data. It just don't allow you to do something like that. If you're doing that, like this thing, so what to do is to use the scope. So, for example, if you could put a curly bracket here, R1 would get out of scope, then it will be dropped. Then now R1 is gone, but then like you can use R2. Yep, make a new reference, no problem. Similar rule for combining mutable references. This one also got an error because our now2 has like it's not a mutable reference, but then like L3 is mutable, so big problem here. Because you use R1 here. So cannot have a mutable reference while we have an immutable one. So yeah. So if you make an immutable reference, so that needs to be the only reference, right? Let's see. Yeah. Cannot as mutable more than once. So it's not just it can be multiple immutable. If it's immutable, so it's not just you can't have like mutable reference. If you have other immutable references, also a big no-no. So user of immutable reference don't expect the values to suddenly change out of under them. Multiple immutable reference are allowed. So if everybody's just reading, it's fine. You can have as many as you like. But if you have, yeah, so the internet is still very bad. I'll finish chapter 4 and this today. Maybe I'll try again later today. Again, like it's really bad. So yeah, so multiple immutable reference is fine because everybody just reading it. But if someone is potentially changing it, then that need to be the only one. Data has the ability to affect anyone else. Fringe line occur before the mute. Yep, so this is no problem. If you print it out, it's no problem. So like you can't use it. Yep. Yeah, immutable row is fine, but if you use it after, then like because R3 can potentially change it, then if you use R1 again, it's a big problem. Okay. So okay, so I think it's fine if like you have multiple references. You can only have one mutable one, but if you have a mutable one, if you use the immutable one again, then it will have a problem because you may potentially change it, and it's a big no-no. R1 and R2, and after, yep. So they don't overlap, so it's fine. Yeah, this is very confusing. I guess you would get used to it, and also the compiler will let you know what's going on. What's this? Dangling pointers. Never be dangling reference. So it won't, like, so if you have a pointer pointing to something, it won't get free. Yeah, so reference to nothing. Yeah, so it's a, yes. Yep, so you can't do that. Okay. Yep, at any given time you can have either one mutable reference or any number of immutable reference. Reference must always be valid. Two rule of thumbs. That's it. Slice type. Oop. Okay.